Welcome to the another lecture of a data science playlist. In this lecture, we will cover the topic classification and regression and decision tree. Uh, by starting the classification and regression are two fundamental concepts in data science and machine learning used for predictive modeling. Both the classification and regression used for making predictions the over any data set. Now, studying classification and regression independently, classification is a type of supervised learning used to predict categorical outcomes. The task is to assign input data into one of the predefined categories or classes. Here we're taking example predicting whether an email is spam or not spam, or classifying a patient as having a diabetes or not. Here we have made the prediction that the email is spam or not, and the patient having the diabetes or not. As we know, both are used for making the predictions. Now, studying regression. Regression is a type of a supervised learning used to predict continuous numerical outcomes. The task is to find a relationship between input variables, features, and a continuous target variables. Here we're taking example predicting a house price based on size, location, and other factors. Uh, the both classification and regression used for the prediction or making over the model, but the main difference is that here the prediction is made over the numerical outcomes. For example, house price based on size, location is a numerical data. So here the prediction made over the numerical data, and in the regression we made prediction over the categorical outcomes. uh, we can take out the conclusion that classification and regression are both essential tool in data science for predictive modeling. So now understanding classification and regression, we come on the topic regression modeling. Regression modeling is a statistical technique used to model the relationship between variables. It helps to predict the value of a target variable based on one or more predictor variables. The goal of a regression analysis is to understand how the dependent variable changes when one or more of the independent variable can change. As we've studied in classification and regression, we make prediction over the categorical and numerical data. Here we make here the goal is of regression modeling is to use independent variables and identify the changes in that one or more independent variables. Now, after studying regression modeling, we come on the decision tree. A decision tree is a popular supervised machine learning algorithm used for classification and regression tasks. As we have studied classification and regression used for prediction, so what algorithm we make on that data set to make a prediction, that algorithm is called the decision tree algorithm. That decision tree algorithm consists of two algorithms, CART algorithm and C5.0 algorithm. We will understand these one by one. Before understanding this, we understand the model of a decision tree. The decision tree consists of a node and branches, where node represent a decision point and branches represent possible outcomes and the possibility of outcomes of the decisions. Now, coming on the CART decision tree algorithm using Python. A CART algorithm is one of the most popular technique for constructing decision tree. It's used for both classification and regression tasks. In classification, it uses the Gini index to split node, while in regression, it uses mean squared error. The difference is that in classification it uses Gini index to split nodes, and in regression it uses mean squared error MSE to find the best splits. It means it works differently for both classification and regression. Understanding it by code, we come on our code editor, which is Google Colab. Uh, this is the following code we have used here for um, card algorithm. Firstly, we have imported all the required libraries and we have load our data set, and after loading the data set we have um, um, split that data set into training and testing data set, and after splitting that data set into training and testing, we have trained the model, and after training the model, we make the prediction over that model. uh, we have made the prediction over that model, and we have also studies that for any algorithm or any analysis over the model, the following steps are the necessary. And after making the prediction, we evaluate the model, and finally we get the decision tree by applying the following code. So this is how the output in the tabular form looks, and this is how the tree decision tree visualization looks like. As I have already mentioned, the root node represent the decision factor, and the another leaf nodes represents the predictions over the factor or over the model. Now, after studying CART algorithm, we come on the C5.0 algorithm for building a decision tree. Um, it builds a decision tree by using the concept of information gain and entropy to determine the best split at each node. It has several enhancements that make it more efficient and scalable compared to C4.5. So it is clear that it is better than C4.5. Now see how it works. Firstly, as we have already um, studied, we have to specify all the required libraries for the dataset, and we have load the dataset. After loading the dataset, we have split the dataset into training and test dataset, and after splitting it, we have this is the main difference from the card algorithm. In card algorithm, there's a step we have not applied. This is the main syntax for the C5.0 algorithm. Initialize the decision tree classifier with entropy. So this make different from cart algorithm. After it make the prediction over the model, and after making the prediction, the evaluation is made on the model. After that, we get the confusion matrix and visual decision tree. This is how our tabular form output looks like, and this is how we get our confusion matrix, and this is how our decision tree looks like. uh, Looks like, and here also the leaf node and the root node works similar as a card algorithm. So this was all about the classification, regression, and decision tree. Thank you.